Okay, hi guys. That's Henrik, I'm Brian. We're two IT security researchers from Heidelberg in Germany, working for a small company, ERNW. So we do quite a bit of research, we do hacking, we do various customer projects and consulting. And yeah, we're actually here for the third time. And this year we're going to talk a little bit about 2016 dumpster driving. So sometime in the 80s, hackers went round, got something like out phone books and stuff like that out of dumpsters. Then we had the eBay era where people started buying switches and stuff with configurations. Then you had the time when you started buying old memory disks and stuff and extracted loads of shit from stuff from eBay. And right now we are going a little bit further and we're actually going into... Okay, so I'm taking this one. And well, yeah, now we are going a little bit further and we are going into telco equipment. So the thing is, we know that there was a little bit of confusion about what you're actually talking about. We are talking about eNote Bs, about LTE 4G base stations. And we're not talking about these little boxes that you've got at home. We're actually talking about real cells. So this is a picture we took in summer in Las Vegas. And you can see, you've got a little fence around here. You've got the actual base station. You've got the antennas out on top. And that's basically exactly what we're going to talk about today. The process of buying a real cellular network cell from the internet and, seeing what we can find. So, eigentlich dein Teil. Mach ruhig.
So, because we want to understand what we are talking about, here's just a short introduction to the network and how it is looking like. We also already did that introduction last year, I think, or no, 2 years ago. So it's just a very quick one. So everybody of you, almost everybody, I think, has a smartphone. That's in telco language, it's called UE, user equipment. That one is connected to that antenna. That is the eNote B. That is exactly what we have here in front. That is what our focus or target for today. And that one usually is connected to some computer center at the provider's network. That is the core network, that is that one. There we will have some management servers, the mobility management entity here, that's just one server, it's software. We have some routers, that are those here, PDN gateway, which is called Packet Data Network Gateway. That one is the one which is routing your internet connection, so all your data connection to some other areas. And then, of course, in the backend there will be some databases just for user management, that's the home subscriber system, and maybe some voice systems like IP multimedia subsystem, which is just placed here. So that is just the some more elements in the core network which are interesting, but for us the antenna is relevant and the interfaces of the antenna to the core network.
Okay, so the stuff that we're looking at, the typical environment, we showed a few of those pictures also already 2 years ago when we started our research in LTE. So basically the thing that we've got down there is exactly what you can find in the fields. So somewhere stashed away in the cupboards you'll find a base station. Perfect. Otherwise you might actually find them somewhere on the side of the road looking like this. You've got very strong physical protection. You've got 1, 2, 3, 4, 5, 6, 7, 8 screws. So if you've got a screwdriver, you go in, you open it. Of course, officially all these boxes are secured via alarm systems. But there again, there are so many base stations out there. If you actually go in and you kick the base station once per day for 2 weeks, let's see how many technicians will actually come out in the 3rd week. And what we then wanted to really look at is what actually happens if you remove the screws. What can you do? What impact can you have on the network and what will you actually find inside? So, basic idea, understand how the base station works. Well, we've done that previously. Try to find a base station, so that's something that we talked about 2 years ago. And it did actually take us something like a year to properly find a fully functioning working setup on the internet. So what we've actually got at home, in the office at the moment is the eNote B. We've got a 2-meter antenna. We've got the remote radio head. So basically we've got a fully functioning setup. So exactly to that setup, the main parts that you have is, you've got the baseband unit, which is basically the box that you can see down there in the rack. Exactly in there, outside of that, you've got the remote radio head. That's usually something like a gray box that you can see on a cell mast just below the antenna. Or I think if we look at this picture, those actually down here are the remote radio heads. So you've got the base stations back here. Then you've got fiber optical cables going here. And what those boxes mainly do is they take the digital signal that comes in via fiber optical and then translate them into an analog signal, which then comes out by a simple coax cable. And then, goes up here and hits the antenna. Then, yes, as said, you've got the antenna. As said, the one that we've got, it's great for playing around with, but we wouldn't actually want to stand next to it while using it. Because, as said, it's a 2-meter antenna. It's actually there to, cover parts of a city. And if you've got something like that in your office, you won't necessarily want to switch it on that often. All that stuff is connected to, a power supply unit. There are stacks of sensors in there. If you open one of these boxes, you've got humidity sensors and stuff, and, well, a little bit of external equipment. The interesting part is you actually need a power supply of minus 48 volts. When we got in contact with that equipment first, we actually thought we would need plus minus 48 volts, meaning you've got 0 in the middle, you've got minus 48 on the one side, plus 48 on the other side, and as such you've got a differential voltage of 96 volts. But actually if you look at the stuff, you really only need 48 volts, so you go in and you simply turn plus and minus and you've got the power supply that you need, which for us is the box that we've got on top. Then as I said, you will need an RRU if you actually want to transmit data. Sadly, we weren't able to bring that with us because the RRU itself is, I think, about 30 kilos, and it's a little bit complicated to take it on the plane. So, the core part that we're interested in, the way things are, is where all the logic happens, which is exactly the thing that you've got down there. As you can see, there is an empty slot on the top. And basically, the thing that we've got in the bottom is the digital unit LTE. So that's actually the actual, blade that you put in there that does all the work. So a few things that if you start working with it, you'll need to learn a few names. So for Ericsson, for example, you're looking for a digital unit, LTE, WCDMA, or GSM. And with other vendors, you really have to look for different terms. So if you hit eBay and you look for eNote B, you won't find a lot. You'll find the 2 books on eNote Bs that are on the market, and you might find a little bit of cables, but you really have to go out and you have to look for something like a DUL, and you'll find them on eBay very easily. So, variants of eNote Bs, as said, there are small boxes. You've got home eNote Bs, which you can place in your flat. There are something like microcells, which, are used in, let's say on something like a construction plant or something like that, when you've got to cover a larger area. And we've got macro cells, which is exactly what we've got here. Now, the interesting thing about the eNote B is it's actually the termination point for every kind of encryption. So you've basically got, if encryption is enabled, an IPsec channel that goes from that box into the core network, and you've got a different encryption channel which is between your mobile phone and the cell mast. So basically, the transport layer encryption all terminates at the eNote B. So of course, for an attacker, it's highly interesting to go in there and to see what you can get out. So, our exact lab setup. These are a few of the terms that you need. For Nokia, for example, it's a Flexi BTS. For Huawei, you're looking for a BBU and the LMPT. Ericsson is what we've got here. And there the important part is, we're not here to talk about Ericsson products. The Ericsson product was exactly the first one that we were able to get for a good price, and we bought it. We've looked at other implementations, and you'll have exactly the same issues as we've got here. So, ignore the name Ericsson, just look at it as a typical E-Note-B that's out there, and yeah, be happy or cry afterwards. So, our lab setup, basically everything that we've got. A hard part is the actual power connectors, because quite a few connectors in the telco domain are proprietary. So you really have to go out, you've got to find the connect plug, so you've got to make them yourselves. As said, we bought it as a whole set. We were lucky we had everything that we needed with it. So that's basically exactly our antenna. That's about 2 meters. Best thing actually is the little sticker on here, which a colleague of ours put on there. He actually put a note on there saying picocell. And every time when somebody sees it, he looks at it and says, oh, that's a little bit too big for a picocell, isn't it? But yeah, that's the way things go. This is our complete lab setup at the moment. So this is the box that we've got with us. We've got power supplies down here. And we've got another few base stations that we're working on at the moment. So eventually, if you want to sit down, put a lab together, if you have a budget of something like, say, $2,000 to $3,000 and you know what you're looking for, then you can buy the stuff and you can start hacking and breaking stuff. So it's not cheap, but it's still affordable, depending on your budget. So first thing, you get the device, you want to connect to it. And you've got a large stack of various connectors, and you've actually got to sit down and work out where to actually plug your cable into. So when you look at it on the left-hand side, you've got a few modules where you can put in GBIX adapters, which basically is the fiber output going towards the antennas or the RRU. You've got a socket which is named GPS, which should be a normal RJ45 or normal Ethernet socket, which actually in the field is there to connect a GPS adapter. So one approach is that if a technician goes into the field, he just puts the base station there, the base station gets an IP address via DHCP, gets the domain of some configuration server in the DHCP answer, finds its own position via GPS and can basically configure itself. So, as good as that is for a technician, it's just as good as for us as attackers. Because, there are open interfaces there and they will talk to us. And basically, those are the interfaces TNA and TNB, whereas TNA is also normal Ethernet, and TNB is for a GBIX over fiber. The other interesting part is the LMT ports. That's something that we talked about in our talk last year, which is the local maintenance terminal. So basically a technician in the field will go, that's where he will connect his own laptop to debug the device. For our setup that we've got, basically the local maintenance terminal, local, is actually exposed via the remote interface. So in that situation, the local terminal would also be available from the core network. So it makes stuff a little bit easier for us. Then the first part. You go in, the first sniff, and well, you'll see stacks of ARP requests, which of course for us was really nice, because ARP at least means that the device is doing something and it's working and there might still be something on it. We had a quick look at that, and you can see, if looking into detail, we've got 2 VLANs, VLAN 2 and 3. So what you do, you go in, you set up a Linux virtual machine, you configure the VLANs, and you set up both VLANs, and then you start spoofing a few IP addresses. So as you've got the ARP requests, you know exactly to which IP address the E node B wants to connect. And we basically spoofed the IP addresses, so we actually gave the IP addresses to the interface. It's a white box approach, we don't have to spoof. And as soon as those IP addresses get available, we can see that SCTP traffic comes in. So from that moment on, as soon as the IP addresses are available, the device will try to connect to its own core network. And as such, when the device hit the market, it wasn't reset. So it's still the configuration as it was in the field, which of course for us doing dumpster driving is exactly what we wanted. So from there on, we had the device up and running, and that's the moment when you actually start doing research. And that's where I'll pass over to Henrik.
Yeah, so first, there were a lot of interfaces like Brian explained. The first interesting one is the signaling one. That is the SCTP stuff you see here in the Wireshark. That's the signaling plane. So the eNode B tries to connect to the core network and do some stuff. So we focused first on that one. Then we have to keep in mind that there are still some maintenance interfaces, so these are very interesting. We will have some remote ORM functions, and of course later we will also jump to some physical attacks. So we have that base station directly here with us, so let's take a look at what we can do having physical access. Anyhow, we wanted to understand how the devices are working and what we can do. And of course, at the end we want to be root on the machine somehow. Good, so transport interface. Transport interface can be implemented in two ways. We have that as one interface which is connected to the core network. That is that one. That is split up into two logical parts, one for the user plane, one for the control plane. So control plane means just configuration pushes and so on. And then we have the transport data of your phone calls, which are forwarded to the router. So to both, of course, we want to have access somehow. But then there is another interface which is, so physically it's the same, but logically it's called X2. That is a interface where you can talk to other eNode Bs in your provider network. So one eNode B can talk to another eNode B to say, hey, I'm under heavy load, please take over some phones, or please make your cell a bit louder to have a big coverage, something like that. So that is why that interface is very interesting. In theory, that interface should be protected via IPsec, so that you can get out of the standards. But it is more or less optional because there is a node. If that interface are trusted, for example, physically protected, there is no need to use that protection. Yeah, what does it mean? Brian already showed on the pictures there are some fences, so at the end what we have seen is that there is no IPsec in place. So that is how our configuration is. And that is one base station which has been out in the field, so obviously there is no IPsec used because that was a physically protected one. And we could try to establish a connection. So here you see a lot of SCTP inits. We wrote a small tool for that called fake MME, that is just faking that as one connection, and then we could establish a connection. It's just basically just one message which is necessary. It's called S1 setup request. That is sent from the eNode B to the core network, and we just have to answer with a setup response. And then we are in. It's just one message, and that is a kind of authentication. But the authentication is just based on an ID you see in the setup request. So the answer of that message is quite easy. It's just sending an ACK back. Having access to that interface, it was possible to send some tracing messages. Okay, in our environment we don't have much UE, so tracing and tracking is not possible to show. But we could push some radio access network configuration, like changing the cell ID, make it louder, make it transfer that cell to some other eNode B, something like that. But also interesting is that radio access beware functions, which means establishing calls. That is also done via that interface. maybe for later use, we also can try to establish a NAS transport, which means forward of authentication information. So that is a kind of advanced man in the middle for getting authentication data from your phone. We haven't done that yet, but that's probably something we will focus on later. But access to that interface was very easy with that fake MME. We also wrote some scanners to enumerate that user ID numbers coming from that eNodeBs. It's called SN1 AP enum, which is already published 1 year ago at Code Cafe. And we have some S1 AP scripts to just inject that messages to our fake MME Python script. So with that one, we could send all the messages. And that is working quite good. On the theory, we've shown that 2 years ago, so we quickly jumped over to the maintenance network because that was quite new for us. What does it mean? So that LMT stands for Local Maintenance Terminal. But in our eNodeB, it is not only local, that interface is also reachable remotely, so via the transport. That is just a flag you can configure on your device. So that is quite more comfortable. We even don't need physical local access. It is just enough to have network access to the network somehow. So what can we see here? There are 2 VLANs configured. So these messages are coming over VLAN 2, and there is a second VLAN called VLAN 3. And the VLAN 3 is just that OAM network, so all the maintenance stuff which can be done. What is running there? Let's take a look to an Nmap. We have FTP, we have SSH, we have Telnet, very great. We have HTTP, we have some other HTTPs, some older ones, 8443, and we have some high-range port, we will explain later, 56834. That is more or less a standard configuration of that Ericsson eNodeB, but gives us an idea what is possible. So, taking a look to practice, so how is it looking like in a real-world scenario? Sometimes your eNodeB is standing under an error condition. That means there is a fault state, so something crashed and somebody has to restart that machine. Under that conditions, an engineer is moving on site. He connects to the BTS with some tool and will access some debug, some monitoring information. And then based on the information he gets there, he can restart it, change the configuration, whatever. That depends a bit on the setup of the eNodeB and a bit on the manufacturer, how he is doing. I know from Nokia, for example, it's not possible to change configuration. He just can access some monitoring configuration and then must connect via USB to the device to flash some new configuration. So there are some really fancy methods. But that one is just possible via a special tool. What was quite easy for us to get that tool, because the tool you can just download on the HTTP server on the device. So very easy to access that one. But as we have been on that website, that was, taking a look to the nodes, what's standing here, it's very, it's quite small, but you need Java Runtime Environment 5.0. So that's very old. It's from 2004, I think. So, and it's out of support since 2009. So our first problem was to find a virtual machine running Java 5. So we had to install Windows XP. Let me now show you a demo.
So that was actually sadly kind of one of the largest challenges that we had throughout this project. You know, actually getting old equipment that would work with the old device. So, there you go.
Yeah. So we had to install a Windows XP machine, what even means, hey, every engineer must use Windows XP by a provider using Ericsson. So that's interesting. And then we downloaded the tool, installed the program. Where is my mouse? Let me check.
Yeah. So we're nearly there. So basically, as Henrik said, this tool is there for an engineer who's in the field to be able to fully debug and configure the device. Basically, the configuration on the eNote B is exactly the same as when we bought it, with one little difference. As we are also working on the RF part, we decided to, change the configuration a little bit to remove a few errors. So, of course, as the eNote B usually lives in a rack, there were stacks or hundreds of warnings and error messages concerning that the fans were not there, the power supply was not answering, the humidity sensors were down and stuff like that. So that's something where we decided to actually deactivate a few sensors in there, just to reduce the output of error messages so that we're actually able to do some proper debugging. Because, if you've got log files with hundreds of lines, it's not fun to work with. So, perfect. So the VM just crashed. Windows XP for the win. What should we do in between?
Oh, let's talk about something different.
What different? Vorschlag. So, let's think. Yeah, let's do a part of the story. So basically, when Henrik will start the manager in a second, you'll see one of the biggest problems that we had in preparing this talk. So we are hackers, and the way we work is we want to go in and we want to show people how to break stuff. Our intention was to give a presentation on how to break the authentication, how to get into the device, how to circumvent any kind of security measures, and actually get in really deep. Sadly, we are not able to give you exactly that information. Not because we failed, but simply because there wasn't any security in place. The moment when you go in, let's break authentication, you see there isn't even a login screen. And there also isn't even a way to set a password. So basically a little bit frustrating for a presentation like this on breaking stuff. But there again, might make life easier for other people out there who actually want to start. And there it is.
So back to Windows XP. So that's the manager. If you just start that one, you can see here, maybe you just type in an IP address, some name that's local, you can make comments, and then you click on connect. And now my IP connection is also gone.
Nearly there. So basically, as Henrik said, what we've got here is exactly the tool as you can download from the base station. So makes life easy. We've just got to fix the IP addresses now. And it died due to not having a connection. So that's yet again something. It's something that we've also seen with other vendors, that where one would expect that you need some kind of external tool for working with the devices. Quite a lot of telco equipment really brings all the tools that you need. So if you buy something on the internet and you want to access it, check the web server and there will be something like an exe installer for whatever configuration tool you need. Yet again, making life easier for us.
Yeah, so that's now the tool. It's connected just via Ethernet to the TNA port, so that's the first port which is also used by signaling network. And here we can also have that remote access. What we can find here, there are some categories we can just choose off, like equipment which is standing here, and we can go through the device or through the configuration stored on the machine. That is basically some IDs we see here, badly readable. On the left, we see some configuration, some elements of the device which have been in that previous configuration. So it was a whole rack. It was not only that device, it was a whole rack with multiple eNote Bs where that one was standing. So obviously that was not a lab one. We have here some possibilities to change configuration. Here is always a list coming where we can change the IP address, where we can change the cell ID, whatever. For example, if we just select here the radio network tab, then we have here the radio network where we also can see which cells have been configured on the device. So here, top left, we see the cell IDs which have been served by that device. And if we want, we can now change them. We can also access the frequencies which have been used somewhere down here. Here it's called the ERFCN, so we can play around and use that device for our own purposes, for example. There are also some security options somewhere, but you see how it's going. Also very interesting, do you want to do that? Look. Yeah. Okay, so also very interesting here, there's an alert tab where you just can access the alerts of the device which are currently running and which have been in past. So we see the problems that E0B had some years ago. For example, if you go to the event log, yeah, obviously the license feature had some problems in the past. There have been some maintenance, such stuff. So very interesting what you can see here, everything. So that is how that's working, and that is everything accessible without any authentication.
So basically, yet again, the log files, so as the device came from the network, and you know, we've got the ARFCN, we've got the cell ID and stuff, and that of course also gives us the possibility to, you know, work out whom the base station actually belonged to, which we've got in the slides later on. And also some of the configuration we've seen on a different base station that we also bought on eBay, actually also gives us the possibility to work out where exactly in which town the base station was actually used. So, you know, it's lots of information and data that is disclosed on these devices. So the slides are nearly back. Nicht in der VM? Okay, good.
So here we go. Let's continue. So that is how it's looking like. You have that log files everywhere. You have some alerts. You can access almost everything with that tool, and you can also change that one. Having a look again to the standards, that should not be possible. So even in the standards there is called, there shall be the setting up and configuring E0B shall be authenticated and authorized. So in our E0B that is not in place. And that anyhow should be, that is how the standards are saying it. What else could we see? There is FTP, there is Telnet, and there is SSH. We've seen the element manager is running on a totally outdated Java, so wherever that client software is running on, that will be very vulnerable, not only because it's Windows XP, it's also because of Java. The element manager was not asking for a password, and if we now take a look to the communication of the element manager, it is based on HTTP, which so not encrypted, so it's just getting some configuration via XML, making some GET requests via HTTP, so no security in place. And it's using Java GEOP, which is an, is also a kind of element-based query language where you can push configuration and also get some of the configuration. That is also not encrypted, or not here. So there is, in that element manager, you can switch encryption of that GEOP on. So you can make that somehow secure, but the HTTP will not be secured anyhow. So here it's just plain, also no authentication, no session management, nothing. But you can use encryption if you want to. Well, what else? We wanted to have access to the device, so we tried to connect via Telnet or SSH. They're interesting. The user running on the machine was RBS, or shallow user, which is just a management solution of Ericsson, and the password was also RBS. So quite easy to connect to the machine. The only problem was the SSH running on the device was also very outdated, and modern ciphers are not supported. So you have to connect via Diffie-Hellman group 1 SHA-1. So what really is not very secure. But if you're on the device, you will find a lot of interesting stuff. For example, if you just go through the folder of that machine, you will find some security folders where IPsec keys are stored. So if they are used, unfortunately in our device there have not been IPsec keys, but now we have access to that port. Even if there had been IPsec in place, we now could download the certificates and use them for man in the middle or whatever. Also we find a passwd file, just the normal Linux stuff, which is there was not a good algorithm behind that, so that shallow user of course we cracked very fast, but it was also the password RBS, so not a real challenge. But you can play around with, because there are some commands on the device where you just can access that one. Let's switch to that one.
So we are just going in and connecting to the telnet, or it's SSH? So we're just connecting to the SSH port to give you a little bit of overview what you can actually find when you connect to the device. So as said, as the device wasn't wiped at all, we've got the classical things like log files on there, we've got various configuration data, and from there on, if you've got the base station and if it was actually placed in an interesting area, you might actually also find information from mobile phones that were connected to the cell. So something that Henrik will probably show you in a second is there are actually methods like cell tracing on the device. And there are still, so cell tracing basically is the eNote B will give you some information on its current cell coverage and surrounding cells. And there also is a setting or a command to actually run very simply stuff like user equipment tracing. So this, the eNote B itself is able to create traces and log files on specific mobile phones, which, if they're on the device and if an attacker buys it, lots of fun that you can have with it.
So now I want to connect to the machine via SSH. So first, if you just do SSH with my hardened laptop, it shows the error we have to use Diffie-Hellman group SHA-1. Great. So let's connect with that one. Type in RBS and welcome. So on the machine there is running OSE 5.5, which is a real-time OS. It's a kind of Linux with some special stuff running on it. If you type ls, that's better readable now. There we see how it's set up. Let's go into the root folder. So here we go. So that is the main directory. There we have some volumes called FFS, D, zip, C, J. So C, D, and J are the main volumes. It's just a mirroring where the configuration data is on several partitions on the device. And then the main volume, so that three ones are mounted through a gzip volume running on some memory at the device. That are the other ones here. So interesting for us are the mounted volumes. It is C, for example. Here we have some folders like security. Typing with John Hand. Here we have all the keys. So we have some security config files. That Corba security, that is that GEOP stuff. And we have the IPsec folder, but here nothing was in. Here is the passwd. Here you see the very secure hash of the password. So you see it's quite easy stuff running on the machine and it's not hard to break it. So, Celody, self-tracing, what's noch here?
So as said, there are stacks of log files on there and we're just going to go in. This, for example, is some log data that we found. Sadly, it's only cell traces, so it's it's no data on actual devices that were connected. but it gives us a very interesting insight at you know, what the cell actually looked like while it was in the field, and what other surrounding cells were. So yet again, it gives us quite a few hints to actually be able to put the device into some place in the field so that we know where it was running.
So then you have some folders to access just some binaries running on the device. Those are a lot of binaries. We are currently on to do some reverse engineering of that ones. There are also some Java applications like that web server and everything what is related to that element manager, so the maintenance tool. So that is still a lot of work. We found some denial of service scenarios, like if you just have a big load on the HTTP server, the whole device is crashing. So the whole eNode B is crashing, for example. That is kind of ridiculous that the whole machine is crashing. Good. Let's go back to our slides. And that's, it's me. So again, what could we see so far? No IPsec on our interface, so whether for the control plane or for the maintenance interface. The RBS, very simple, telnet, and everything what we've seen was unencrypted now. Again, it was from a real-life scenario. Good, some more. We had access to the device. We could make some dumps of that gzip volume. That's very interesting. So if you make a dump of the whole entire file system, you have, it's starting with 1F8B, so it's gzip. So the machine seems to do some one-time zipping or unzipping of the memory. Also, there will be some one-time decryption of the configuration files. That is also very interesting. So we are currently working again on the decrypting stuff. So there's somewhere in some of that binaries there is a hard-coded password. We haven't said yet, but to most of the configuration files and binaries of the whole operating system, we already have access via just unzipping the volume. That is a bit looking like that. So we have 1F8B. There was one more magic behind. We had to flip the bytes because of that big endian, little endian structure. So to read everything here, we first have to change the values. Before that, it was looking like that. Here you see the alphabet. So C, B, E, D. So that's looking not correct. GFT. So we are flipping just the bytes, and then we have access to the file system dump. And we find some interesting binaries of the operating system. So even where we did not have access on the shell, where we have the ppc elf strip pl.conf. That are PowerPC binaries, like for implementation of the radio interface itself. That gives us some more possibilities to do reverse engineering, to do some analysis in future. Also interesting on that shell was a command called ramlock, which is just dumping some information out of the boot process. There we could see which processor architecture is used. So it's a Motorola MPC85. We also see all that gzip volume that that are used. So that's quite interesting.
And you know, one of the interesting parts is exactly down here. So obviously the eNode B isn't really happy. It wasn't able to find its magic. So, well, little things that you find from time to time. So yeah, as said, we looked into the configuration. We wanted to find out whom it belongs to. And we find that it's got the MCC, so the mobile country code 311, and the mobile network code 660. So the base station itself actually is from the US. And the actual operator behind it is Metro PCS. So, it's not on the slides. Metro PCS is, well, a US-wide operator that was bought by T-Mobile US a few years ago. And basically, you know, it seems to be one of their old devices that maybe while they fused together, they just dumped or they got rid of. So yeah, for us, of course, interesting to actually see whom the device belongs to. A few other things that we found. So if you saw it before, the username RBS actually wasn't in the passwd file. there was only cello user in there, which, you know, was a little bit confusing. And after playing around a bit and actually using passwd to just see what happens if we change the password, it actually turns out that cello user and RBS are basically the same user, and it's something like an alias on the device. So if you change the password for either of them, the password for the other one also changes, which is, well, not critical, but slightly strange.
I mean, it's also a problem because cello user is used by the management system of Ericsson, and usually that password or the connection is hard-coded. So if you change that, I'm not sure if that management is still working. That means maybe for all Ericsson users, that password will work, because otherwise the whole management system will not work anymore.
So yeah, as said, we've got SSH enabled with old keys. So yeah, basic hardening. We've got the cell and UE traces. As said, we had a look into those files. They sadly don't really contain any highly interesting data for us, you know, playing around with wise. We can see where the cell was placed, but sadly it's exactly, oh, it's not on here. Sadly there are no actual UE traces where you can actually extract user data. But you know, it's dumpster driving. Something you find something that's good, sometimes you don't. Now, the slightly strange thing, Henrik talked about the GOP remote session. If you look through Wireshark, and you can perfectly see it here, kind of, all the connections that we've seen and that we've worked with so far go to private IP address spaces, which, you know, gives you the hint it's an internal network. And, you know, that's the way things work. Strangely enough, exactly one connection, which is the connection going to this IP address, goes to a public IP address. We know from our experience that there are operators out there who will simply misuse public IP addresses in internal networks. You know, it's a closed network, so why not reuse an IP address? But it was really strange for us to see that it was exactly only this very one single IP address. And yeah, it's running GOP, and it's basically a configuration interface. So, you know, we had a little insight into it doing the classical whois. Yeah, that picture is really great. If you can see it somewhere here, it's actually a telco operator based in Tehran, in Iran. So, you know, it's really a very interesting random happenstance that the American Metro PCS base station is misusing a public IP address which belongs to an Iranian operator. So, for us, it looked highly strange. As said, we know that it's not unusual that these IP addresses are misused, but, you know, it wasn't quite what we were expecting. And also, we can actually see that the eNode B, just time-wise, was still used in 2013. And we also know that the IP address space actually already belonged to that Iranian telco in 2012. So, yeah, we, of course, didn't look at the remote IP address. The port is down, so wherever it used to connect to, it's either gone or it was a misused internal address. So, yeah, strangely interesting. So, in summary, you know, security is based on IPsec. We said that it's, of course, bad that the operator doesn't use IPsec. From our point of view, the operator actually was rather, you know, lucky. Because otherwise, when we bought this device, we would have had a valid IPsec client certificate to connect to the operator's network, which, of course, is something that you don't necessarily want to leak. And, you know, if you think about the fact that they didn't wipe the device before selling it, so we actually bought it from an official vendor who does telco equipment surplus. So we know that it comes from, you know, a clean source. It's not just eBay and somebody found it on the road. So yeah, it's complicated. You know, we've got kind of hard-coded passwords. We've got weak management protocols. So on application layer, there's next to no security available. So basically IPsec is the only line of defense that really is there on the transport network, which, yeah, you know, we actually had expected to be at least a little bit harder to get in. And also the thing is the local maintenance terminal. We talked about that in our talk last year quite a lot. You know, the moment when you go in and you open actually one of those cupboards on the roadside and you actually try to access the eNode B, you're in. There's nothing in place that will stop you. Of course, as said, there's something like an alarm system, but you're creative hackers, so you'll find a way to circumvent that. And after that moment, you've got the eNode B, you've got everything and all tools that you need to get it up and running and to start breaking it and playing around with it. And you know, the stuff that we've done was in a lab environment. But basically it's just as easy with all the devices that you can find in the field. And you know, we hope that hopefully loads of you will actually start looking into telco too and actually break stuff and show the guys out there that, you know, something has to change and we have to get the whole stuff a little bit securer. And with that, thanks for your attention. Any questions? Perfect. Otherwise, if you've got anything, we'll be around. We're happy to talk and share. So, see you. Thanks.